Hello, here we are at problem 7a. It says we've got two people, A and B, and they run around a circular track. So we've got a track ready here because there's no graph no diagram on the paper, so we need to draw our own diagram as we read along. So they are running around a circular track and they start from diametrically opposite points, meaning they are on two different ends of the diameter. A over here, B should start from here, and A runs clockwise. So A runs clockwise, and B runs counterclockwise. So B runs counterclockwise. Okay, I'll draw B's path within, B's trace within, in case it becomes messy later. And A and B run at a constant but different speeds, all right? They meet for the first time after A has run 100 meters. So after A has run 100 meters, they meet for the very first time. Let's say it looks like this. 100 meters, and they meet for the first time, and after that they move on from there. They meet for the second time after B runs a 150 past their first meeting point, meaning B has covered another 150 before they meet for the second time. And meanwhile, A goes all the way from the other side, and now they meet here. And that's the whole story. And we are supposed to find the length of the track. So let's say the length of the track is C. It's a circumference of the circle. And since they are running at some constant speeds, so the equation we will need to solve for C will have to do with the speed. Let's see. For the first time, for the first meeting point, A has covered 100. How about B? B actually has covered half a lap minus 100, right? Half a lap minus 100. That should be half C minus 100. And how about A? A has covered 100, and that's it. This should be VA to VB because the time is fixed, and the ratio of a distance should be the ratio of a velocity, the ratio of speed. And let's see if we can get another VA to VB, and if we can get some other expression for VA to VB, then we can get a new equation, and then we can solve it for C. Let's see, from the first meeting point to the second meeting point, B has moved 150. Okay, how about A? A has gone this far, and this is actually, okay, this might be a little bit tricky, but if you study the graph carefully, this is actually one full lap minus 150, right? This is complementary to 150 here, so it should be C minus 150. Okay, here we are. Expression 1, expression 2, these two expressions should be equal to each other because they're both VA to VB. And so 100 to a half C minus 100 should be C minus 150 to a 150. Okay, then need to solve this equation. Okay, it's a quadratic one. It's not that nice, but anyway, I think we can solve it. Let's check. 1, 5 followed by 3 zeros on the left side. I used the diagonal rule, the butterfly rule, and for the right side, it should be half C squared minus 100, right? It's minus 75 and okay, minus 175 C and a plus. Oh, come on, what's that? This number comes again, which is a good thing. So it's 15000 again. So these two can be removed at the same time, meaning, okay, 175 is just a half C. Okay, 1 C can be taken away, and C should be 2 times 175. That is exactly 350. So the length of the track is 350 unit meters. Done.